morning, my fellow friends. We are going to start by our learning outcomes. Okay, first of all, we should be able to define the terms orbital. Then we should know to state all the four quantum number of an electron in an orbital. Okay, the first is the principal quantum number. Then the angular momentum quantum number. Then the magnetic quantum number. Electron spin quantum. Then we also should know about how to sketch the 3D shapes of s, p and d orbitals. Okay, the Heisenberg's uncertainty principle and the Broglie's postulate of due nature of electron had brought different perception about electrons. The idea of electron moving in a circular orbit around the nucleus was totally discarded. Edwin Schrödinger, an Estonian physicist, introduced the field of study called the quantum mechanics to solve the problem of finding electrons and the energy state of the electron in an atom. The theory of the quantum mechanics explained the behavior of particles in the atomic and subatomic realms. These particles include protons, particles of light, and electrons. Since the electron of an atom determine many of its chemical and physical properties, quantum mechanics is foundational to understanding chemistry. Electrons possess both wave-like and particle-like properties. The position of an electron is described by a probability distribution map called an orbital. Orbital is What is orbit? An orbit is a path for an electron of travel around the nucleus of an atom. What is an orbital? An orbital is the space around the nucleus of an atom where the probability of finding electron is very high. Okay, my dear friends, now I am going to show you the Broglie's postulate. Here is the concept of orbitals from the Bose atomic model. This is the example of model. This is the orbit. And now I'm going to draw the nucleus that we call proton number. Electrons actually move in a circular orbit of certain radii with specific energy around the nucleus. Okay, my dear friends, this is the model atom. And here is our atomic orbital described. Actually, in an atomic orbital, we have to know about the energy level and distribution of electron density in a region. There are four sets of quantum numbers. The first one is principal quantum numbers, which is in n. Okay. It determines the energy level and is always in position positive. And is always in positive integer, such as it can be 1 or 2 or 3 or more. So, the higher the energy level, the bigger the size of the orbital. Therefore, the energy increasing. The second one is angular momentum quantum number, which is in L. It determines the shape of the orbital. The value of L depends on the it depends on its principal quantum number. So we can use the formula N. Okay, my dear friends, in order to find the angular momentum quantum number, we have to multiply 1 from the principal quantum number. Here, the principal quantum number will determine the angular momentum quantum number. Now, we will show you how principal quantum number determines the angular momentum quantum number. As example, n is equal to 2, L equal to n minus 1, which is the formula. So make it. After substitute the 2 into the formula, angular momentum quantum number, the last answer is 1. So here we can know that the angular momentum quantum number is 0 and 1. Third one is magnetic quantum number, which is represented as m. It determines the orientation of orbital in space. The number of permitted value of m is equal to 2 times angular momentum quantum number plus 1. It indicates the number of orbital with different orientation for a particular value of angular momentum quantum number. Therefore, angular momentum quantum number determines magnetic quantum number. The integer number can be -1, 0, and 1. The last one is electron spin quantum number, which will be presented as S. It determines the direction of spinning motion of an electron on its own axis. could be clockwise or anti-clockwise. Therefore, the value of electron spin quantum number is either positive half or negative half. And this is our overview. Okay, here we are coming to our last subtopic, that is draw the shape of orbital. Actually, we have three orbital, S, P, and D.
Okay, first we introduce S orbital. The angular momentum quantum number equal to 0. The shape of S orbital is spherical. S orbital became larger as energy level increased. Okay, now we start from 1S. First, we draw the spherical shape. Then we put its arrow. Its name is 1S. This we label X, Y, and Z.
Okay.
Second picture is 2S. It has the same picture, but it's larger than 1S. You put its arrow. And label it X, Y, and Z. It 2S. Okay, first picture is PS.
Okay, the arrow must be here. First, make sure you draw your arrow. If you find out the drawing of shape of orbital is too hard, I will advise you to draw the arrow first, then label X, Y, Z. The next is 2PY. As I say before this, draw the arrow first. This must be the Y, X, Z. Now we look for the another example, 2PZ. The arrow, this is Z, this is Y. Okay, this is our Y and this is our Z. Here is our p orbital diagram, and now I'm going to continue with
D orbital. D orbital.
this is our Y and this is our X. Here is our p orbital diagram is finished. Now we are going to continue with our D orbital, the last orbital.
D orbital. Angular momentum quantum number equal to 2. Its shape is cloverleaf. equation. dzy, dyz, dxz, dx squared minus y squared and dz squared. Because it have 5 possible value of m, -2, -1, 0, 1 and 2.
Now I'm going to draw the first diagram, that is d equal to xy. Okay. First, as usual, we start with our diagram. We will label this as z, label this as y, as x. Okay. This is the shape of clover leaf. Okay. Then the arrow. The next shape is dxz. Here I label as z and here x. This is y. The third shape is dxz. As usual, first is the line. Okay, and determine your basis. You see, here is y, so y, z, z. And I'm going to start to draw. And here is my axis. I label this as z. Okay. And we are going to continue with another diagram which is a little bit different from the others. That is our dx2 minus y square diagram. Look here carefully. It should look like a 3D because x square minus y square. Okay, we start to label. This is our x and this is our y. And this is our z. The last diagram is our dx square.
This.
It's really different from the others diagram. Okay, a small correction. This one should be here, because it has to look like a 3D diagram. And here's our 3D diagram. And the next is dz square. The drawing is really different, and in 3D shapes we should be in 3D shape. Donut, normally we'll call as donut shape. And here is our donut shape. Okay. A ring. It's called a ring. crossing each other. Okay, now we are going to label X, Y, and here is our Z. That's all our d orbital shape.
Okay. From our presentation, we hope all of students can apply it in exam. This is very simple if you really understand what we present. So, we hope that you get an excellent mark in exam in chemistry subject. Okay. From our presentation, we hope all of students can apply it in exam. This is very simple if you really understand what we present. So, we hope that you get an excellent mark in exam in chemistry subject.
Okay, a small correction. This one should be here, because it has to look like a 3D diagram, and here's our 3D diagram, and the next is dz square. The drawing is really different, and in 3D shapes we should be in 3D shape. Donut, normally we'll call as donut shape. And here is our donut shape. Okay. A ring is called a ring, and the arrow should crossing each other. Okay, now we are going to label X, Y, and here is our Z. That's all our d orbital shape. Okay, a small correction. This one should be here, because it has to look like a 3D diagram, and here's our 3D diagram, and the next is dz square. The drawing is really different, and in 3D shapes we should be in 3D shape. Donut, normally we'll call as donut shape. And here is our donut shape. Okay. A ring is called a ring, and the arrow should crossing each other. Okay, now we are going to label X, Y, and here is our Z. That's all our d orbital shape.
Our conclusion.
Okay, we are already, this is our mind map. Okay, we are already learned, chapter 2 atomic structure, and we learned about the definition of orbit, definition of orbital. If the question they ask determine the definition of orbit or orbital, this is the answer. The keywords to travel around the nucleus of an atom, and this the probability of finding electron is very high, orbital. And then we also learn about the main thing in the chapter 2, that is our quantum mechanical model. We learn about 4 quantum mechanical model. Quantum number, first is principal quantum number, the n represent n, and the angular momentum quantum number represent L, and the magnetic quantum number represent the words the alphabet M. Then the electron spin quantum number, the alphabet represent S. And we also learn about the shape of orbital, which are very important in chapter 2. Okay, this is not going to end here, it will continue until part 5, chapter 5, I'm sorry, chapter 5. Okay, we learn about the s orbitals and p orbitals, d orbital. S orbitals is about 3 drawings, and p orbital about 3 drawings, and again 3 drawings. But actually for s orbitals we have only one drawing, that is the spherical shape, and d orbital we have 5 drawings. And
our conclusion.
okay, we are already, this is our mind map. Okay, we are already learned, okay, chapter 2 atomic structure, and we learned about the definition of orbit, definition of orbital. If the question they ask the determine the definition of orbit or orbital, this is the answer. The keywords to travel around the nucleus of an atom, and this the probability of finding electron is very high, orbital. And then we also learn about the main thing in the chapter 2, that is our quantum mechanical model. We learn about 4 quantum mechanical model. Quantum number, first is principal quantum number, the n represent n, and the angular momentum quantum number represent L, and the magnetic quantum number represent the words the alphabet M. Then the electron spin quantum number, the alphabet represent S. And we also learn about the shape of orbital, which are very important in chapter 2. Okay, this is not going to end here, it will continue until part 5, chapter 5, I'm sorry, chapter 5. Okay, we learn about the s orbitals and p orbitals, d orbital. S orbitals is about 3 drawings, and p orbital about 3 drawings, and again 3 drawings. But actually for s orbitals we have only one drawing, that is the spherical shape, and d orbital we have 5 drawings. And